What is machine learning? In this video, we're going to cover the basics of machine learning. Specifically, we're going to start with a definition of what machine learning is. Then we provide a comparison between artificial intelligence, machine learning, and deep learning. Then we discuss how machine learning works. We talk about different types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. We talk about the prerequisites for machine learning, and at the end, we provide some examples of applications of machine learning. So what is machine learning? Machine learning works on the development of computer programs that can access data and use it to automatically learn and improve from experience. This enables machine learning to help us do complex tasks, such as 3D printing of entire houses. By using algorithms and large datasets, machine learning can automate design and planning, helping to address construction challenges such as structural integrity and material efficiency. It can also customize designs based on environmental conditions. It can help reduce cost and time while increasing precision, and has the potential to transform the construction industry. As another example, consider our personal assistants like Siri or Google Assistant or Amazon Echo. They all use the power of machine learning to help us with our everyday tasks like playing our favorite music or ordering food or voice controlling our home appliances or requesting rides from Uber and much more. As we said before, artificial intelligence is a technique which enables machines to mimic human behavior. This is key because it's how we figure out if our calculations and work are on the right track, by seeing if they can imitate human behavior. We're using this approach to take over some of the work humans do, with the aim of making things more efficient, streamlined, and accurate. AI is a broad field that covers many different technologies. Some examples of artificial intelligence include IBM Deep Blue Chess, electronic game characters, and self-driving cars. These are just a few examples of many ways that artificial intelligence is being used today. Machine learning is a technique that uses statistical methods to allow machines to learn from their past data. This means that machines can use past inputs and answers to help them make better guesses in future attempts. Google's search algorithm and email spam filters are examples of applications of machine learning. And then we have deep learning, which is a subset of machine learning. It uses algorithms to allow models to train themselves and perform tasks. AlphaGo and natural speech recognition are two examples of deep learning. Deep learning is often associated with neural networks, which are a type of black box model. As a black box model, it's difficult for humans to track how deep learning models make their predictions. However, deep learning models can still be very effective at performing tasks. We will have a deeper dive into the world of deep learning later on. Now let's see how machine learning works. To understand how machine learning works, let's have a look at the following diagram. In the first step, we start by training our data. Then, we feed the trained data into a machine learning algorithm for processing. The processed data goes through another machine learning algorithm. And now it's time to test our work. We bring in some new data and run it through the same algorithm. In the next step, we check the predictions and the results. If we have any reserved training data, now is the time to use them. In the next step, if the prediction doesn't look right, let's say it gets a thumbs down, it's time to circle back and retrain the algorithm. Remember, it's not always about getting the right answer right away. The goal is to keep trying for a better answer. You might find the initial result isn't what you wanted. That's okay, it's part of the process, and it can depend on the field you're working in, whether it's healthcare, economics, business, stock market, or something else. the results can be very different. So we need to try out the model, and if it's not giving us the result we need, or if we think we can achieve better outcomes, we retrain our model. And in the final step, we keep refining and retraining until we get the best possible answer. That's how machine learning works. Now, let's look at different types of machine learning. We can see that we have supervised, unsupervised, and reinforcement learning. We'll go into each one, get a good idea of when and where to use them, and what they're all about. In machine learning, we use lots of different algorithms to deal with tough problems. Each one fits into a certain type. So we've got three main types of machine learning algorithms: supervised learning, unsupervised learning, and reinforcement learning. Now let's get into what each of these learning methods really mean. Supervised learning uses labeled data to train machine learning models. Labeled data means that the output is already known to us. The model just needs to map the inputs to the outputs. An example of supervised learning can be to train a machine that identifies the images of animals. Here, we can see a trained model that identifies the picture of a cat. Unsupervised learning uses unlabeled data to train machines. Unlabeled data means that there is no fixed output variable. The model learns from the data, discovers patterns and features in the data, and returns the output. In this example, our unsupervised model uses the images of vehicles to classify if it's a bus or a truck. So the model learns by identifying the parts of a vehicle, such as the length and width of the vehicle, the front and rear end covers, roof, hoods, the types of wheels used, and many other features. Based on these features, the model classifies if the vehicle is a bus or a truck. And we have reinforcement learning. Reinforcement learning trains a machine to take suitable actions and maximize reward in a particular situation. It uses an agent and an environment to produce actions and rewards. The agent has a start and an end state. But there might be different parts for reaching the end state, like a maze. In this learning technique, there is no predefined target variable. An example of reinforcement learning is to train a machine that can identify the shape of an object given a list of different objects such as square, triangle, rectangle, or a circle. In this example, the model tries to predict the shape of the object, which is a square. Now let's look at different machine learning algorithms that come under these learning techniques. Some of the commonly used supervised learning algorithms are polynomial regression, random forest, linear regression, logistic regression, k-nearest neighbors, naive Bayes, support vector machines, and decision trees. And these are just some examples of algorithms used for supervised learning. There are so many other algorithms that are used in machine learning. For unsupervised learning, some of the widely used algorithms are k-means clustering, singular value decomposition, fuzzy means, partial least squares, a priori, hierarchical clustering, principal component analysis, and dbScan. Similarly, there are so many other algorithms that can be used for unsupervised learning. And some of the important reinforcement learning algorithms are Q-learning, SARSA, Monte Carlo, and deep Q networks. So as we said, there are so many different algorithms available to us, and choosing the right algorithm depends on the type of problems we're trying to solve. Now let's look at the approach in which these machine learning techniques work. So supervised learning methods need external supervision to train machine learning models, and therefore the name supervised comes. They need guidance and additional information to return the result. It takes labeled inputs and maps it to known outputs, which means you already know the target variable. Unsupervised learning techniques do not need any supervision to train any models. They learn on their own and predict the output. They find patterns and understand the trends in the data to discover the output. So the model tries to label the data based on the features of the input data. And similarly, reinforcement learning methods do not need any supervision to train machine learning models. Reinforcement learning follows trial and error method to get the desired solution. After accomplishing a task, the agent receives an award. An example could be to train a dog to catch the ball. If the dog learns to catch a ball, you'll give it a reward, like a treat. And with that, let's focus on applications and types of problems that can be solved using these three types of machine learning techniques. So, supervised learning is generally used for classification and regression problems. For example, you can predict the weather for a particular day based on humidity, precipitation, wind speed, and pressure values. As another example, you can use supervised learning algorithms to forecast sales for the next month or next quarter for different products. Similarly, you can use it for stock price analysis or identifying if a cancer cell is malignant or benign. Unsupervised learning is used for clustering and association problems. For example, it can do customer segmentation, which is segmenting and clustering similar customers into groups based on their behavior, likes, dislikes, and interests. Another example for the applications of unsupervised learning is customer churn analysis, which is a process of evaluating and understanding why and when customers stop doing business with a company, with the aim of developing strategies to improve customer retention. And finally, we have reinforcement learning. Reinforcement learning is reward-based. So for every task or every step completed correctly, there will be a reward received by the agent. And if the task is not achieved correctly, there will be some kind of penalty. Now let's look at some examples. Reinforcement learning algorithms are widely used in gaming industry to build games. It is also used to train robots to perform human tasks. Multipurpose AI chatbots like ChatGPT or Google Bard use reinforcement learning to learn from the user input and adjust their output based on previous conversations. And with that, we have come to the end of this section on supervised versus unsupervised versus reinforcement learning. Now, let's see what are the prerequisites of machine learning. So, the first one is computer science fundamentals and programming. Many machine learning applications today require a solid foundation in basic scripting or programming. It is not just about writing complex algorithms, but being able to understand and manipulate the underlying structures. Without a good grasp of these fundamental skills, it will be challenging to make the most of the machine learning tools available. So, if you're seriously considering diving into machine learning, it's advisable to brush up your programming skills. Intermediate statistical knowledge. A fundamental understanding of probabilities is needed in the world of machine learning. You'll often find yourself asking questions like, if A is happening, what's the likelihood that B will occur? Or if there are clouds overhead, what are the chances it will rain? These type of questions, rooted in probability, are at the heart of many machine learning algorithms. It's all about predicting outcomes based on given conditions. So if you're keen to make significant strides in machine learning, it's definitely worth familiarizing yourself with the basics of statistics and probability. Linear algebra and intermediate calculus. Linear algebra is key as it requires you to grasp the concept of plotting a line through your data points and understanding what it represents. This is the primary idea behind linear regression models, where you draw a line through your data and use this line to compute new values. Regarding intermediate calculus, it involves having a basic understanding of differential equations. No need to be a master at it, as the computer handles most of the heavy calculations, but it's beneficial to recognize the terminology when it pops up, especially if you're diving deeper into model programming. And data wrangling and cleaning. Perhaps one of the most significant aspects in this field is mastering the art of tidying up your data. It's often said if you input bad data, you'll get bad data out. But if you have good data in, it's more likely to have good data out. The quality of your data can greatly influence the outcome of your machine learning models. Therefore, understanding how to effectively clean and organize your data becomes a critical skill in ensuring the accuracy and reliability of your results. Now, let's look at some examples of applications of machine learning. We have object detection and instance segmentation. Object detection and instance segmentation are two different but related tasks in machine learning. Object detection is about recognizing and finding items within a picture, like telling different cats apart, for example. On the other hand, instance segmentation is the next step that separates these identified objects from the rest of the image. These techniques are put to use in various ways, including identifying different elements in an image. Moreover, segmentation can further isolate or cut out specific components. One popular application of object detection and segmentation is the Google Pixel phone's Quick Snapshot feature. This feature uses machine learning to identify objects in a user's current view and then overlay animated stickers or filters on top of those objects. This can be a fun and creative way to add a personal touch to photos. We also have license plate detection. This is a pretty cool use of machine learning. Imagine a car driving into view and the system is able to spot and identify the license plate on that car. This application of machine learning can be particularly useful in various situations like security checkpoints, parking lots, traffic control, or even for charging tolls without making the cars stop in the middle of a highway. It showcases how machine learning can extract specific information from a larger context with accuracy. And we also have automatic translation. Automatic translation, powered by machine learning, has been a game changer in breaking down language barriers. It is the driving force behind the instant translation that you see on foreign websites, making the content accessible in your preferred language with just a click. It is also the technology that enables tools like Google Lens to provide real-time translations of signs when you point your camera at them. Whether it is browsing the internet or navigating a foreign city, machine learning has revolutionized our ability to understand and interact with the world. Truly, automatic translation is an impressive testament to how machine learning can bring the world closer together. Thank you for watching this video. The world of machine learning applications is vast and ever evolving. It is one of the fastest growing sectors in technology, and the possibilities are endless. What I have shown you here are just a few of the highlights, a small sample of what is possible. But there is so much more to come. In the next video, we will shift gears and explore deep learning, a subfield of machine learning that made many of the machine learning advances possible. See you in the next one.